All right, good morning, guys. Today we're going to talk about cross-country planning. I know I said I would have this last night, and I apologize that it's not up and available. I just had a lot of master's assignments to take care of, but I will still have it out before class. That way, you guys can look at it at any time and use it as guidance to complete your cross-country project. Okay, so if you just follow the things that I'm telling you in here, you should be fine on the cross-country project. Okay, so cross country is when we travel from one airport to another, right? When we leave the vicinity of our area and go to another airport. I'm sure most, if not all of you, are trying to work up to those restricted ATP minimums, right? That the 141 affords you. And cross country time, by definition, is when you travel from airport to airport and the distance, the straight line distance between the two is at least 50 nautical miles. So that all becomes loggable cross country time towards your hour requirements for your ATP and everything. So remember 91.103 we talked about a long time ago, right? But that's the regulation that says that we are supposed to know everything. All of the information that is available, we have to familiarize ourselves with. And in essence, that's what cross country planning is, right? We need to figure out what our route is going to look like, what type of airspaces we're going to be dealing with, how much fuel we need to bring, right, for comfort and legal purposes, and NOTAMs, and just a lot of things. Okay, so cross country is really the culmination of everything that we've gone through so far. You're going to see elements and little bits and pieces of everything that we've talked about in order to kind of get to the end result. Right, so that's why we have you guys do the cross country planning. Is yes, next course 201B for you guys. You will go out on cross countries. You'll have some dual cross countries with your instructor, and then you will eventually get to the point where you will be going out on a cross country by yourself. So you need to have some idea of what a cross country entails. And then again, it's just the combination of everything, right? So if you can plan a cross country, then that shows that you are competent in all of the areas that we have already talked. Okay. So actually, before I move on, let's talk about all of the materials. So you will need a St. Louis sectional for this. If you have a current paper one, that's super great. Just for the ease of making this video lecture, I'm going to go ahead and use SkyVector. So feel free to use SkyVector. You can prove that it is current. I will try to remember to show you guys how to do that, but it should be a viable source. You just have to be careful with how you use it. You also need chart supplement. So the last time I bought a paper chart supplement was back in 2018, and I still have those relics in my office. So what we'll do for this cross country is we'll just go online and we'll search up the chart supplement information. And the chart supplement essentially is exactly as the name implies. It's an additional um, I guess, a place where information is stored that just can't be listed on the sectional. As you know, there's not a lot of space on the sectional for things like that. You just get basic airport information. So more in-depth information, including even a diagram of the airport in some cases, is available via the chart supplement. And again, we'll use that in a little bit here. FAR AIM is just there for guidance, right? If you have any questions about regulations, that's where you go in there. Sometimes there are practices that we adapt or adopt from the AIM particularly. So useful book, right? You're going to need the POH. How are you going to know how much fuel, how much time it's going to take to do stuff if you don't know how your aircraft performs, right? How are you going to make sure your weight and balance is within limits? So you need POH. Plotter. Again, if you're not going to have a paper sectional, you don't need it right now. I really hope that whoever your instructors are have you do the cross country planning the manual way. That way you get a sense of how to do that, right? We kind of spoil you guys, but hopefully they kind of teach you that a little bit. There'll be a little bit in the presentation here, but I'm not going to have you guys do that if you don't have the paper sectional. E6B is a computer that we can use to calculate these things. We'll talk more about how the E6B works in class, and I might make a separate video on using the E6B. VFR Navlog, I'll have that for you guys for the project. You don't need that, and then pencil, obviously, and then weather briefing, and we'll talk about how to get that in a little bit here. All right, so while cross-country planning is the same to some extent, some people have like different methodology in some areas, and that's okay, right? As long as it's safe, it makes sense. As long as they tell you why they want you to do it that way, go ahead and do it the way that they want you to do it. Um, some people fill in more of the navlog than others, but I guess for the purposes of the project, just kind of do what I do. That way I can score you guys. Okay. And when you go to check ride, when you plan a cross country, what it really comes down to is, of course, did you do good planning, right? But can you answer all the questions they have to ask about your planning? Can you explain why you chose to do a particular thing? Why you chose to bring as much fuel as you brought? Maybe why you decided to not travel to the airport in a straight line. Maybe there was some airspace or something. Okay. So check rides, usually the check airmen use the cross country as a vehicle for almost everything else, okay, because it is that culmination of everything. So what we're going to plan today, as an example, is going to be a cross country to Kilo Papa Hotel Tango. And the scenario I've created is we're just going to fly in, and gives us a reason to go there. Okay. So when we cross country plan, I usually split it up into 2 days, right? You have the day before, and this is stuff that is non-weather contingent. So these are fixed values that will not change despite the weather of the next day, right? And then everything you're doing that second day has a little bit more reliance on the weather. For instance, figuring out pressure altitude and density altitude and that sort of stuff, you have to wait until the day of to kind of do. So we're going to start by figuring out our course. We're going to pick out some checkpoints. We're going to measure distances, consider variation, magnetic course. Deviation, you can kind of do the day before. I'll talk more about that when I get to it, but it might also be a second day thing. And then fill in all the information that we can about the airport. And then weight and balance we can usually do the day before if you're a student at SIU, right? Because we expect you to go on cross country with full fuel. Okay, so plotting a course is fairly straightforward. The plotter is a tool that's just kind of used to draw a straight line between your departure and destination airports. And once you have that line drawn, then before you do anything else, make sure that that route um, doesn't present any issues, right? So what I mean by that is there say some special use airspace that you probably would not be able to go through. So if you were, I don't know, in an area where there's like restricted airspace on the way, then you would likely have to plan around that, right? I would say don't expect ATC to give you a clearance, or if there's an MOA you know to be hot and you don't want to risk going through the MOA, then I would say plan maybe a different route, a different altitude, or something like that. Okay, so make sure that your route doesn't have anything that's going to be a huge problem to you. So if there are no problems, then keep in mind that the line you just drew is in relation to true north, right? So this is what we call true course, okay? And in order to find out what the true course is of the line, we have to align the top of the plotter, and I'll have pictures of this on the next slide, but we have to align the top of the plotter with our line, and there's a little eye that runs along the top of the plotter that we also need to put against the line and also a line of longitude. Okay, so an intersection where your line that you drew and the line of longitude meet up, put the eye right there. And if you just follow the line of longitude up to the top of the arc on your plotter, then you should be able to find your true course. Once you find out what it is, go ahead and write it down on the nav log. So what this looks like here, you can see I've drawn my line, and I'm sorry for the millions of lines here because I've gone on a lot of cross countries using this sectional. But the darkest of the lines is the one from KMDH up here at the top, near one of my cat's paws, all the way down to Henry County, which is where we're going. So I've drawn the line, and I suppose you could probably do better than me in centering it up. But I've drawn the line and everything. And as you can see, there's not really anything significant along the way, right? I don't see any like huge obstacles or anything. The only thing that might give me a little cause for concern is Barkley Regional Airport, and that's class Delta that just goes up to 2,900. But we know we're going to plan an altitude of at least 3,000, so that's not going to be an issue for us. And then we go over a town, and there's not really much else on the way. So this is a problem-free route. And in that second picture over there, I've gone ahead and I've put the top of the plotter against the line, so you can see that it's lined up, right? And what I've done is I've slid the plotter along the line once it's lined up to a point where the line goes through a line of longitude, so those lines that run north and south. Um, and you can see that I have the little eye or the hole um, on the top of the plotter in the middle of the arc there, on that intersection between the line that I drew and line of longitude. And then all I have to do from there is follow my line up, or my line of longitude up anyway, to the top of the arc on the plotter. And you can see that puts us somewhere between 160, 150, or 340 and 330. The catch with that is just you just have to kind of be logical about it, what makes sense, right? So if we're going from KMDH down to Henry County, right, we know our heading is going to be southeast. We don't know exactly what it's, I'm sorry, our course is going to be southeast, right? We don't know exactly what it's going to be at this point, but it's going to be southeast. So on my arc, the values that make the most sense are going to be our 160 and our 150. So we just figure out where between those the line runs, and it looks to me like it runs about 154. Okay, so what I would do is I would call my true course 154. So on the nav log here, I've got KMDH on the left for my checkpoint. So this is where you're going to put all the stuff you're going to fly over, and then eventually your destination and some other things. But for right now, just put your departure airport because you don't know how many checkpoints you're going to have or any of that stuff for right now. And then 154 is what I've written in for true course. So for each of these columns, be careful, okay? Because there are two boxes um, for each row, if that makes sense. So you can see that the top two here are shaded darker than these two here, okay? So the top box in each, I guess, pair is your true course, right? So I've written the 154 in the top box for all of these. And then below that would go our wind correction angle whenever we figure that out. So just make sure you're writing the 154 in the box that's specifically designated for true course. Okay, I know there's a lot of boxes here, but I promise it'll fill in as time goes on. Okay, and right now I've just written in an arbitrary number of 154s. Like I said, I don't know how many checkpoints I'm going to have because I haven't picked those yet. If I need to erase a 154, I'll do that, or if I need to write more of them, then I will. Okay. So the next thing we need to do, oh, and then before I continue, I am so sorry. Let me go to SkyVector and show you guys. Let's see. Oh, nope. I want to, I'll keep them. Okay. Let me go to SkyVector before I forget and show you guys how I would get the same information. So up here in the top left corner, if you go to SkyVector, this is the flight plan box. If it's not here, just hit flight plan and it should drop down. Okay. In this box, write in both your departure and your destination. Okay. And a magenta line should populate and it's going to say some information. So it gives us a direction, so 157 and 96 nautical miles for a distance. Feel free to keep the 96 because that will become useful as we calculate our distance and measure that. We also use the plotter for that. But we can keep that as a reference for total distance. However, the 157 is not quite what we need at this point. So what I want you guys to do is go to navlog, and when we hit this button, what populates is of course a navlog, kind of like what we're doing. There's just not a lot of information in it. And you can see here, right? I don't see a 157 at all. Well, how'd they get the 157? What they did is they added this 154 that they got for the track and the variation of 3. So they added that together to give us a magnetic course, and that's not what we want right now. We eventually will get there, but right now we just want whatever is in the box for track, okay? And that is the same thing as true course. So the 154 is what we would want. So if you're going to use SkyVector for your project, just get whatever is in the track box and use that as your true course. Okay. All right, let's go back to the PowerPoint here. Oh, I went all the way back to the beginning. Okay. All right, so next is choosing our checkpoints, right? So checkpoints are visual points that we can identify from the airplane, right? They should be large enough or distinct enough that we should have no trouble verifying them, okay? And it can be a variety of things, right? Around these parts, we've got both the Mississippi River, the Ohio River. So chances are, if you're going on a cross country to the south, you'll probably use one of those rivers as a checkpoint. You can use an interstate. You can use railroad tracks. You might have to have kind of a secondary checkpoint that kind of verifies that you are at that particular part of the railroad tracks. You can also use airports, right? Most airports have a different runway layout, and they've usually got a town that's near them. And you can use that combination of information to verify that that is the airport that you're expecting it to be. So checkpoints, generally speaking, you want them 10, 15, maybe 20 miles apart. Sometimes there's just not enough stuff on the chart that allows you to have the checkpoints that close together. So you have to kind of work with what you have. So it's okay if it's not perfectly spaced out. And a couple checkpoints that are givens that are not necessarily visible checkpoints are what we call a top of climb and a top of descent. So when we are using that climb chart to plan how long and how far and how much fuel we're going to burn during the climb out, we also use that information to figure out where exactly on our route we're going to reach our top of climb, or kind of the neighborhood of that, right? Remember that climb chart is more of an estimation at best because it does not um, account for wind, right? That's the main deficiency of that. And then top of descent, right, is the point at which we would decide to start our descent down to whatever our pattern altitude is going to be at the destination. So those we'll plan along with the checkpoints a little bit later. But when you pick your checkpoint, right, draw a hash mark along your line or your route that you've drawn on the sectional to signify where the checkpoint is, right? And then once you have the hash marks for your checkpoints, go ahead and use the nautical mile side of the plotter to measure the distances between the checkpoints, and then you would write those on a nav log. So on the plotter, there is both a nautical mile side and a statute mile side. You want the nautical mile side. So make sure you're using that to measure the distances. Um, we will figure out how far it is to top of climb and top of descent soon. What I would do at this point is I would go ahead and look at the POH and just kind of see what kind of the maximum climb distance is going to be. So that way you can pick a checkpoint that's a little further than that. Hopefully that makes sense. So if our top of climb, let's say like, I don't know, the top of climb is not going to be any more than like it's not going to take any more than like 12 miles, right? What I would do is then I would pick a point that is greater than 12 miles in distance from the airport. That way I have time to reach my top of climb before I reach my first checkpoint. So I'm pulling up the POH right now on my iPad here. And let's see. If I go to the nav3, okay, so I'm looking at like the Cessna S model, 172S model POH. And for instance, I see from like sea level up to, I don't know, 6,000, let's say, is a distance of 13 nautical miles. I know today we're probably not going to climb up to 6,000. So what I would do is I would just make sure that my first checkpoint is greater than 13 miles from the airport. You might want to allow for like, I don't know, 5 to 10 miles um, after your top of climb for your first checkpoint. But yeah, I would just use that as a reference. And then once we actually do the planning for the top of climb, then we'll know exactly where that is. Okay, so if we go here, right, I've got my line and everything all drawn up. Um, on the right, I guess maybe I should have flipped these around, but on the right side, you've got the hash marks that I've made for my checkpoints. So it looks like the first one I picked after the top of climb was going to be, looks like I-57. So I've drawn a hash mark there. And then my next one I picked is the Ohio River because that's very distinct and identifiable. And then Barkley Regional Airport I decided to also use because I can pick that out in a pinch. And then Mayfield, both the airport and the town I'm using. And then after that, I want to say that's at the top of this, or no, maybe we're using Murray. Yeah, I think we're using the town of Murray out here. So it should be pretty much right to our east at this particular point. Okay, so that's what I've chosen. And then the picture on the left, what I'm doing in that one is just measuring the distances. So you can see on this side of the plotter, this is the nautical mile side. But if I flipped the plotter over, I would have statute miles. So just be careful there. And again, you can kind of use SkyVector to help yourself out in this endeavor. You can take that total mile or mileage and everything and then figure out how far it is between the checkpoints and then make sure that it adds up to the total mileage. I believe it was like 96 nautical miles. Okay, so that's how I'm doing that. And you can see, right, even in this left picture here, is that my first checkpoint is like 16 and a half miles away, which means I've given myself adequate distance to complete that top of climb before I reach that first checkpoint. So I want you guys to do the same thing. All right, so and this is what my nav log looks like after that. So I've got my top of climb added. Again, we don't know exactly where that is, but we know it won't be any greater than 13, 15 miles. So I've picked something a little beyond that. I've got I-57, I've got the Ohio River, I've got Barkley Regional, I've got Mayfield Graves, and then a beam, I believe Murray's Airport, and then there's also the town there. You can write whatever you need to write in these to remember what exactly it is you're looking for. Sometimes you might have additional notes. And then my top of descent is sometime after that, and then the destination airport. Okay, so that fills out that part of the nav log a little bit more. And what I would do at this point is go ahead and write a few more 154s in that true course space again. So I'd write another one between a beam KCEY and top of descent, and then from top of descent to KPHT. And then I've got distances, right, between my checkpoints. I've measured what I can measure at this point, so 20 miles between I-57 and the Ohio River. Again, there's not really much between there. Yeah, there's maybe a railroad track. You could use that, but I figured that the interstate and the river were my best bet. Okay, so 20 miles between those two. And you can see, right, every pair of boxes goes between two different checkpoints. So essentially what you're finding every single time you make an addition in the row there is something in relation to the next checkpoint, right? I know it's a true course of 154 from I-57 to the Ohio River, and there's also 20 miles, right? I know that at this point. And it's 12 miles from the river to Paducah, 19 miles from Paducah to Murray, and then 10 miles from, or not Murray, I'm sorry, Mayfield, and then 10 miles from Mayfield to Murray. Okay, and then I just don't know about that top of descent yet. So I've left that and the top of climb blank. Okay, so that's what I've got so far. All right, the next thing to consider is the variation. So remember, variation is the difference in location between true and magnetic north. So true north is what we understand to be the geographic North Pole, right? That is literally the top of the globe. And the magnetic north is what our compasses point to. So if we were anywhere near the North Pole, you would find that if you followed your magnetic compass, it would not lead you to the actual geographic North Pole. The magnetic north actually shifts a little bit every single year. And in order to figure out what that difference is, right, variation exists for that reason. So the chart that we've been looking at so far, or the sectional, I should say, is plotted in reference to true north, right? So those lines of latitude and longitude all correspond to true north, okay? But what our compass and our heading indicator, as a result, would read is everything in reference to magnetic north. So we have to make that conversion when we're doing the planning so that we are headed in the right direction, right? It's not going to be a huge difference around here if you were to just not account for the difference in location between the two, but there are some areas where the variation is really, really high, okay? And you would be way off. Okay, but here we're talking like 2, 3, maybe 4 degrees, depending on where you're going. So on the sectional, remember, we looked at those dashed magenta lines, right, with the degrees next to them, and that's the isogonic lines, right? So those show that difference, okay? So when you are considering how much variation to account for, find the two like isogonic lines on either side of each checkpoint, and then figure out which one is closer to the checkpoint. Whichever one is closer is the one that goes on the nav log. There's no need for interpolation here because, I mean, it's already hard enough to adopt a specific heading on the compass, right? It's hard to go for 257 rather than 258, for example. So we don't want to make it any harder than it already is, right? So just take the closest whole number and then throw that on your nav log. Now, the rule with the isogonic lines and the variation is if it is a west variation, and how you would know this is it would say however many degrees and then west. If it is west, then we add that to the to our information, right? We don't quite have true heading yet, but that is kind of what you would add it to. You can add it to other stuff, but you would add if it's west, okay? And then if it's east, then you would subtract, okay? So the way to remember that is west is the best, east is the least, right? So if I see an isogonic line that says 5 west and my true course, as it is in this case, is 154, then I would go ahead and I would add that 5 to the 154 to give me 159 for my magnetic course. Okay, if I saw a isogonic line that was close to my checkpoint that said 1 degree east, then I would subtract 1 from my 154, right, giving me a magnetic course of 153. We'll talk about the difference between course and heading in just a second here, but I want to show you what that looks like. You can see here in the shot on the left side, right, we've got an isogonic line that runs almost flush with the edge of the sectional, right, the left edge. And if you follow it down far enough, you can see that it says 2 degrees west. And then if we open our sectional further on the other side, kind of far away, right, you can see a line that almost runs against the right edge that says 3 west. Okay, so we know for sure we're adding, right? But we don't know if we're adding 2 or 3. So whatever is closer is what we're going to add, okay? So for I-57, let's see here. Or no, let's go ahead and go off of Mayfield since it's right here, right? So Mayfield Graves, kind of in the middle of that shot to the left. If you look carefully, you can actually see the 3-degree isogonic line off to the right side of that picture on the left. It's kind of running just between land between the lakes, so just on the east side of Kentucky Lake there. And if we compare the locations, right, I would say for Mayfield that that 3 degree west line is a little bit closer than the 2 degree west line. Okay, so in that case, for that checkpoint, I would write 3, like +3 on my nav log, right? Because I'm adding 3 because west is the best and east is the least. Okay, but if you are closer to our airport, you might find that the 2 degree west line is a little bit closer. Why am I making this harder than it is? Let me just go on Sky Vector here. So if we go back to Sky Vector, right, we can actually see these things a lot better. Okay, so let me zoom in a little bit. Okay, so you can actually see here, right? We've got our route, we've got the airport. If you look out to the west, yes, out to the west, right? Kind of just on the west side of Lake Kincaid, then you can see we've got a 2 west line that's fairly close to the airport. If we go out to the east, we have to go all the way past Harrisburg to get to that 3 west line. So again, if my first checkpoint after top climb is I-57, you can visually see, right, the place at which I cross it on my route is a lot closer to the 2 west line than the 3 west line. So I would call the variation for that particular checkpoint 2 degrees west, right? So I would add 2, okay? Yeah, I was like, why am I making this harder than it is? Let me just show you Sky Vector, okay? So let me try to continue here. Let's see. There we go. Okay. All right. So this is what my nav log now looks like. Now the column that says magnetic course, true course, with the variation. I learned last semester that I've been doing that wrong my entire life, right? It doesn't really matter what goes in here because you have this information elsewhere, right? But what should really go in here is magnetic course, and that's just your true course with your variation, right? So if we've got the true course of 154, right, from KMDH to top of climb, and we've got 2 for our variation, right, because it was 2 west, so we're adding, then what should really go in this box for magnetic course is 156, okay? Um, so, yeah, it makes no difference to me if you put anything in this magnetic course column. Um, because you will be able to get that information here anyway, right? Um, you just need to choose the appropriate altitude, right? So the reason why magnetic course is important, why we care about that, is because that's what determines our altitude. So if we look in the regulations, I think it's 91-159. Don't quote me on that, but I think that's it. But this regulation says that if we are um, traveling on a magnetic course anywhere from 0 to 179 degrees, we need to have an odd thousand plus 500 for altitude. So that would be 5,500, 3,500, 7,500, something of that nature. And then if we've got a magnetic course of 180 to 359, so in that range, then we would need to choose an even 1,000 plus 500. So that's why we care about that. That just kind of tells us what altitudes we have available to us. And at this point in the cross-country planning, you can see I don't know which altitude I'm using for sure, but I do know that my requirements or the regulations state that I have to have an odd thousand plus the 500. Okay, so 3,500, 5,500. I could even do 7,500, but for a cross country this short in a Cessna 172, I don't think that's necessary. So those I've considered as my viable options, and I'll probably pick one of those. Okay. So again, I don't know why I haven't put in more 154s to complete it. Um, but you can see, right, over time, my checkpoints get closer to that 3 west line, okay? So we got 2s for a while, and then it gets a little closer to 3, okay? And again, all you have to do to get the magnetic course is just add your true course and your variation, and you'd get it. So I have a magnetic course of 156 and also 157, okay, this whole time. So that's clearly within that 0 to 179. Excuse me, 0 to 179 block. Okay, and then I've also got distance information as well. It said 96 on SkyVector. I measured from, I believe, the center of the airport icon, and I used my plotter. And with the plotter, there's just a little bit of error sometimes. Sometimes there's a little bit of rounding that goes on to just kind of give yourself some square numbers for your distances. So that's why my 98 is a little bit bigger than my 96. Okay. And again, I am still missing some distances, but we will figure those out in a little bit. Okay, so let's talk about the difference between course and heading, right? So we know what the difference is between true and magnetic, right? If I had a true course or a magnetic course, the magnetic course has taken into account the variation and the true course has not. Even if I have a true heading and a magnetic heading, right? Again, the magnetic heading has taken into account that variation, but the true heading has not. Okay, so we understand that distinction, right? But course versus heading is a matter of wind. Okay, if we have a wind that's blowing on us that requires wind correction. So in order for us, so what I mean is if we have a wind that's pushing us off course, right? That's not allowing us to track the course that we've set for ourselves, then what we need to do is we need to put in wind correction for that, right? So what ends up happening is that our heading, which is the way we're facing, is different than our course, which is the direction we are actually going, or our track, you might hear it called. That's what SkyVector calls it. Um, so course is without wind correction, heading is with wind correction. Okay, so we have different combinations of these things, right? If I say true course, that means in reference to true north, right, without wind correction. Okay, so that's the direction we're actually traveling in reference to true north. If I say true heading, which you don't really hear of, but if I say true heading, what that means is um, direction we are facing, right? So wind correction angle in reference to true north. So we haven't factored in that variation yet because it's still true, but we have factored in the wind correction because we have a heading rather than a course. If I change to magnetic course, which is what we just found, right? We know that we have accounted for the variation and we're still in reference to true north, right? And then if we have magnetic heading, we've factored in the variation and we've accounted for the wind correction as well. So we have both of those things. And then the last thing is kind of weird. A course heading, how can it be both? Well, a course heading is really the actual direction you're going, right? Plus the wind correction angle. So you have the wind correction in there. And then the thing that makes it different is the magnetic deviation, which we'll talk about in a little bit. But that's essentially the interference of the electronic and magnetic and metal components of the aircraft, right? It causes your magnetic compass to not exactly show an accurate reading sometimes. Okay, so course heading is the very last thing we end up with. Okay, so right now we're hanging out at magnetic course. We figured that out for the purpose of finding our um, like our legal altitude, and then we will change that to magnetic heading when we consider the wind. Okay, but that waits until the second day because remember, second day is contingent on the weather, and wind is part of that. Okay, so we've kind of already talked about this at length, right? But magnetic course is what we get when we factor in the variation to our true course. And oh, it was 159. Awesome. So that's the regulation that says what I said a few minutes ago, right? If we're anywhere from 0 to 179, we need to pick an odd thousand plus 500. If we are anywhere else, so 180 to 359 degrees for a magnetic course, then we need to pick an even thousand plus the 500. So it's kind of reverse, right? The way that I remember it is you would think that even goes with east, right? Because they both start with an E, but even goes with west and odd goes with east. I think somebody says like odd people go east, and that's how they remember it. I've heard, but I just think E and E do not go together. They actually go, they're separated. Okay. So, which altitude should you pick? We kind of already discussed that a little bit, but if there are obstacles that are really high up, and you might see that there's a high maximum elevation figure in an area, if you've got higher things that might pose a hazard or risk to you, then you might do well to pick a higher altitude. If you have airspace to clear, so remember the line we drew goes over Barkley Regional Airport, and that goes up to 2,900. So we definitely need to clear that airspace. We could, I suppose, transition through it, but we really don't want to be picking a cross-country altitude less than 3,000. Okay, so 3,500, 5,500 both give us clearance. And winds aloft is another factor as well, right? So when we get the weather the next day, you might see that the winds aloft at like 3,000 are not so good. You might have headwinds or something like that. But the winds aloft at, let's say, 5,000 or 7,000 um, have a little bit more of a tailwind component to them or less of a headwind component. If you are pressed for time and you don't want to deal with that, then you might pick that as an altitude going down. Now, that's not to say that you will avoid that completely because sometimes you have to go where there is a headwind when you come back, right? Keep in mind that when you're traveling the opposite direction, you will have to pick um, a thousand that belongs to the other hemisphere, I guess I could say. So if we're going down to this airport, right, on a magnetic course of, I think we determined like 156, 157, then I would need a right odd thousand plus the 500. But if I am coming back from that cross country, then I will be on a northwestern magnetic course, which means that I'm going to need an even thousand plus 500. So just keep that in mind when you're planning. Is sometimes you can't get away from headwinds. All right. And then, like I said, I wrote that down in the notes to just kind of see, um, what some viable options were, just to kind of keep that down. The less information that floats in your head when you're doing these, the better. I like to just write everything down, take notes, and then figure it out as I go along. All right. The next thing we're going to procure is the airport information. So there's nothing weather-wise that would really prevent us from finding out about our airport and everything. We need to be aware of the frequencies that we are expected to use as we get close, right? We need to listen to weather. We need to communicate with traffic in the area on the CTAF and other information, right? How long are their runways? Which ways are they facing? Is there a right pattern for a particular runway? Are there parachute operations? Just like all sorts of questions, right? What services does the airport have? We are taking the time now to answer these questions so that we can be prepared. Okay. So the first place we'll start looking is the sectional, and you can get a lot of information off the sectional. Hopefully, the airport information for KMDH is pretty routine for you guys, so you should be able to fill that out pretty easily. But the destination is something that I would look at a little bit closely. So you can see the destination, right? They've got an AWOS and it's 118.825 for that frequency to tune into that. So that's something I would write down. Field elevation is 580. That's also important, right? That gives us information about what their likely traffic pattern altitude is. So that's something I would write down. They have lighting, and it looks like it's not pilot controlled. So I don't know what the deal is with that. Maybe it's always on. I would look in the chart supplement to see if there are notes about that. Their longest runway is 5,000 feet, so that's really good to know. And then their CTAF and their Unicom is 123.0. Okay, so that's information I would also write down based on the symbology, right? They've got fuel services. That doesn't guarantee that they actually have fuel, but they offer services. So they've got that. They've got a rotating beacon if we are going here at night. And then they've also got parachute operations. So that's something that I would be aware of the closer I got to the airport. So that's some stuff you can get out of that. And here's what it looks like if I'm writing all this stuff down. So the destination there, right, there's not really an ATIS, it's an AWOS. If you want to cross ATIS out and write AWOS, that's fine. But the weather, right, is that frequency we looked at. Approach, so I will show you where I got that information on the chart supplement in a little bit. Tower, ground is non-existent there, right, it's uncontrolled. And then your CTAF 123, or yeah, 123.0 is there. Flight service station, I'm not really that concerned about. Um, and then Unicom is the same thing, and then elevation, right? So that's what I would write in this box to get the most information possible. Okay, if I scoot out of this for a second and I go back here, what I can do is I can literally Google chart supplement. So that's what I did, right? I did that. And then what comes up is this link here. So you want to click on this and then click on chart supplement search. And that's what the books look like, by the way. No, I don't have time for Survey FAA, but thanks. Okay, so what you can do is you can put in your identifier um, in this box. So that's where we're going to search for your airport to see if there is a chart supplement page on it. So there is, and don't click on this because this will give you, I believe, the entire chart supplement book, and that's a lot of pages. Click on this, and that should be the page for the airport itself. And lo and behold, it pops up, right? So here is the chart supplement on the airport. So you can see the name, right? The codes, so the IATA code, the ICAO code. This 3 Northwest here tells us that the airport is 3 Northwest of the actual town that it's associated with. So that's cool. It tells you time zone, right, and coordinates. I'm not really concerned about any of that. The 580 here, right, is going to be your fuel elevation. You should be able to get that from the chart, but if not, it's there. We're not really worried about this. This NOTAM file here might also be important. So if you're looking for NOTAMs pertaining to the airport, they might be filed under MKL. So something to just note. Okay, another piece of information that I had drawn really is the runways they have available, right? So this is where I'm getting that information. The chart shows you the overall direction that the runway or runways run, but it does not give you a designation for them. So that's where I'm getting it here, right? So we have 2 and 20 to choose from. And not all of this is really important, right? This is the length. So 5,001 and for the length, and then 100 feet for the width. It's asphalt. H just means hard surface. S, this is, I believe, the weight for a single axle aircraft in thousands of pounds or hundreds. I think it's hundreds of pounds. I think weight per axle, or no, I think it's thousands. But anyway, that's the weight there. Don't worry too much about that. Medium intensity runway lighting is what that means. So if you're coming in and it was dark, they would have that available. This just shows they have run runway end identifier lights for both of those. They've got a PAPI for both ends, which is a precision approach path indicator system, which just shows you if you are on glide path or not. They do have 100 low lead for fuel, so that's good to know. We talked about the lighting already, and let's see. Okay, so the lights are on dusk to dawn, so they don't you can't turn them on. That's why it's not pilot control. They just come on. And let's see here. Airport remarks attended. Okay, that's great. Not on holidays and stuff like that. Let's see. So this is our AWAS 3 that we already found, right? That matches. If you wanted to call and listen to it, you could. CTAF, Unicom. This is where I got the approach from. So if you wanted, there's nothing that says you have to talk to Memphis Center, but if you wanted something like flight following, that is who you would contact eventually. You would probably call them up a little early on when you were closer to our airport, and it would be Kansas City Center at that point. And what they would do is they would give you advisories and help you with traffic separation, and eventually they would pass you on to Memphis Center there. So I put the 134.65 on there as kind of a safety measure, I guess. If I get lost or something and I'm in that neck of the woods and I'm unfamiliar and I need help, I know who to contact and how to contact them. And that's pretty much all of the information that is applicable to you guys. They have a little airport diagram as well. So you can see the runways, you can see the P's, the PAPI, they've got trees on either side. It looks like the terminal and hangars and all that is on the northeast side, right? They've got a runway that was available in the past, but it's abandoned, so they don't even list that. There's some power lines there. So it's nice. It gives you a little bit more to go off of than just the park. Okay. So that's where I got that additional information, and I even drew a little diagram of just the runway. I have the length, PAPIs and everything, to expect those. And yeah, so that's all I have for that. Weight and balance is the next thing. We already know how to do that. So go ahead and record your weight and your flight instructors if you're going on a dual. For this project, you don't have to include another person. You can just have yourself. And look at the POH for all the information that we've gone over so far, right? So find the arm or station that's appropriate to your seat position. If you're bringing any bags or anything, also find the station or arm that's appropriate for that. And then just go ahead and assume full fuel. Like I said, if you're doing a cross country from our airport as a student in our program, you are expected to have full fuel before you leave. So look at your airplane POH, right, to figure out how many usable gallons you can store. I think what I'm going to do with this project is I'm just going to give you probably 172R performance and information. So that's what I will expect you to go off of, even if you fly like the 152, just to keep it uniform for everybody. So I'm sorry, but that's the way it's going to be. And don't forget that fuel is, or 100 low lead fuel specifically, is 6 pounds a gallon. Not forget that. Okay. So because you already know how much fuel you're going to have, as long as you know what's going to be loaded on there, you can go ahead and do the weight and balance. The only thing that will be missing until the day of in a real scenario is going to be your basic empty weight, because you have no idea which airplane you are going to be given when you show up to flight ops. And I guess the question is, are you going to get an airplane? But you don't know what they're going to give you. So there's no way to plan for that basic empty weight and then the moment that is associated with that. So for the project, I will go ahead and give you that information, but for your real cross countries that you are going to do as a 201B, don't expect to be able to enter that information until the second day. So this first day, we're literally doing every possible thing that we can do so that we have less to do in the morning, right? I had 7 a.m. block for most of my flight training, so it was imperative that I did as much as I could the night before because I would have to get up at 5 in the morning to finish the cross country planning. Okay. Um, so that's about all we can do at this point. I know I said I would talk about deviation. Let's talk about that as a second day thing, and why it actually is a second day thing. All right, so right now, let's go to sleep. Let's take a moment to kind of just relax. Okay, it's 5 in the morning. Let's continue. All right, the day of, these are the things we're going to do, right? Everything that we're doing this day is weather contingent, right? So that's the first thing we need to worry about. Once we have weather, we can go ahead and choose an altitude. We can figure out our cruise performance. We can look at time, distance, and fuel for the climb and everything. We can do wind correction calculations. We can figure out where the top of descent is supposed to go. Weight and balance, we can figure that out finally. And then distances, and then we can file the flight plan. And then when we are leaving, we can activate the flight plan. Okay. So, like I said, all of this depends on the weather, so that's the very first thing we are going to do. 1-800-WX Brief is a great source. It is a reputable source. It is a government source, right? So when you go on there and you get a weather briefing, so if I go here, oops, go away. Okay, so if I go here, I'm already logged in, but you would need to create an account if it's your first time. And when you have an account, it keeps record of when you get a weather briefing, right? So if something should happen, which I really hope does not ever happen to anyone, but if something does happen, then this would be something that they would check to make sure you have followed 91.103. Right? If you've gotten a weather briefing, then that's something that you are at least off the hook for. So in here, if I was planning a cross country, I would go to plan and brief on the morning of, and they've logged me out, so I'll log back in. Okay, so I would go here, I would go to plan and brief, and here I would put in my information. So for this one, you don't know which airplane you're going to get, so it doesn't really matter. So you can put in a random airplane. You can choose your flight rule as VFR. Flight type, always G for general aviation. One aircraft, aircraft type, Cessna 172 or 152 if that's what you fly. Wake turbulence category is always L for light. Don't worry about equipment. Departure you do need, so KMDH you can throw in there. And departure time you can put in a few different ways, right? You can choose the date and the actual time, and you can choose Zulu or our time zone. I usually just leave it as Zulu, or you can say minutes from now, right? If you're leaving in the near future, and 120 is the maximum, so 2 hours in the future. So let's say I'm leaving today at I'm actually going on a cross country today at 1 o'clock. So if I convert that to Zulu time, that makes that 1800. Okay. Cruising speed, the formatting is a little interesting for this. If you have questions about how it's supposed to look, you can just drag your cursor over the field and it tells you how it's supposed to look. So for instance, this is 115 knots for my true airspeed. I just made up one. Pick one that's sort of in the realm of possibility, shall we say. So if you have to go in your cruise performance table in your POH, look for something that's kind of like an average speed. Okay, doesn't have to be perfect. Level is your altitude. So for right now, let's just pick 5,500 again. If you want to look at winds aloft, you can pick one for sure, but I just kind of throw one in there that I might use. Don't worry about surveillance equipment or route of flight if you're going direct. Destination is Paris, right? Henry County, so I've put that in. And this cross country is not going to take 2 hours, but I just put 2 hours to make sure that I can see enough of the weather information to make sure nothing is going to change in the course of the flight. Fuel endurance, I'll put something like 5.5 hours. Persons on board, actually, I don't think you have to put the fuel endurance in just to get a briefing. I think this is all the information you need. So if I hit route brief, then I can choose my briefing type. So just leave it as standard, right? You don't want abbreviated or Outlook if this is the first time you're getting a weather briefing. It's too close to the cross-country departure time to choose Outlook, and abbreviated implies you've already gotten a standard briefing. So just get a standard brief. I would leave the check marks as they are. It doesn't matter if you pick web briefing or PDF. I like PDF. So you can see it pops up, right? So it gives us our route and everything. And here you can go through all the weather products and see, right? So the adverse conditions are the very first thing that you're presented with, because these are usually what decide if we're going on the cross country or not. So if you see a lot of adverse conditions, then I would say probably rethink. But I don't see anything. There's no convective SIGMETs, no SIGMETs, no AirMets, nothing closed, no TFRs, anything like that. So continuing, they've got like freezing level information, right? If there are no clouds, we don't have to worry about freezing level. Okay, and then continuing, there is a little bit of an AirMet Tango. So it looks like turbulence, low level wind shear, that will probably be active when we're out flying. So we might get a little piece of that, but this looks like actually a high. You can see it's moderate turbulence between 30,000 and 42,000. So that's not going to affect us. There are no lows. So I guess make sure you see that. Don't be like me and just glance over it. There are no low altitude AirMets. There are high, but we don't have to worry about those. No low-level wind shear down here, no winds over 30 knots down here, so nothing to prompt the release of an Aramat Tango. There's no PIREPs or center weather advisories, anything like that. There is a surface analysis chart, which is helpful, right? So you got that cold front moving in. There looks like maybe a little bit of rain ahead of that, but that's kind of mid-state right now. So with as short as this cross country is, right, I don't think we should be too concerned about that. We've got high pressure system down to the southwest there. Isobars are fairly spread out. So right now it's not really that windy. I don't know if it's going to pick up at all today. Haven't looked that far ahead. You've got METARs, so you can see the conditions of the stations along the route. So everything is looking pretty decent. And then you've also got some cloud coverage maps and everything. You've got wind. Again, it's not looking too strong in this neck of the woods. And TAF data is also important, right? So the closest TAF that we're going to be passing on this cross country is Paducah or Barkley. And you can see that there is a time where there's maybe a scattered at 5,000 layer that begins at 10 o'clock today. And that lasts until about 8 p.m. tonight, according to the TAF. So there might be a few clouds out there. Just make sure that we're keeping our VFR distance from them. So that's important because that kind of gives us an outlook, right, of just kind of what to expect. Winds aloft, this is important. So when we're considering our altitudes, this is what we would look at. So it looks like 5,500 has winds pretty much out of the west, up at St. Louis, and then it becomes more of a kind of southwesterly wind as we kind of continue along the route. I would say Cape is probably the most applicable source for winds aloft because it's the closest to the route. You could consider Evansville, but I think Cape is probably going to just kind of be the best source for us to look at. So 255 at 9, so it's not really strong by any means. It's more of a crosswind for us. And then down at 3,500, it's the same strength. The direction is a little bit different. It's a little bit more southwesterly. So I think either way, we're going to get a crosswind. It looks like maybe the 5,500 is a little bit more crosswindy. If I went down to the 3,500, I might get just a slight headwind on the way down. So I would probably stick with my 5,500 based on winds aloft. So I've kind of made that decision, right? We're looking at this convective outlook for day one, general. So as the day goes on, there could be some activity, maybe. Probably not, though. It's not even marginal or slight. And then there's a lot of information here. There's NOTAMs and everything. So NOTAMs can be about obstructions and things. And by the way, notices to air missions is what they are. They used to be notices to airmen, but there are a lot of air women that we love to have in the industry. So they've changed that to notices to air missions. And there's notes about obstructions and notes about runways, right? So you can see here at the airport, VASI is unused or unserviceable. That's what that really means. And then the reels are unserviceable as well, so you can't use those. So those aren't really a big deal for us here. You can see that there are, so remember it said that the NOTAMs were filed under MKL, which is I think McKellar Sipes or Jackson, I can't remember which one. But anyway, for our airport, right, there's some obstructions, and there's not really much else besides that. The wind cone light is unserviceable. Okay, but that's not really a big deal for us. En route stuff is just talking about some ILSs and stuff out of service. So that's not really a big, giant deal. What would be a big deal for these NOTAMs is if, let's say, runway or destination was closed, right? That might change your plans a little bit or altogether. Or maybe there was, that's probably the best example I can think of. So like airport closures, things like that. Probably the best thing I can think of. Okay. And then as you go through it, there's just a lot of NOTAMs and things, airspace related ones, some IFR things that we're not really that concerned about. So as long as you don't see any closures or anything like that, I wouldn't be too concerned about the NOTAMs. Once you kind of go through your planning, you might take more time to look at those because, especially when you start doing instrument stuff, there's more to kind of be aware of. Okay, so from what I can see so far, it looks like this cross country is going to be doable. Okay, and what I'm going to do is I'm going to keep that briefing for right now because I will have to consult the briefing in order to continue the cross country planning. I believe I already have some preset values in here, and I'll just try to show you how I use them. So let's do this. Okay, so we got the weather brief, and I even have all the fields that you need to put in, right? So winds aloft become very important, and then we can use temperature information to get, excuse me, density altitude. Okay, so what I've done down here, based on the weather briefing I got when I made this, is I looked at the winds aloft and the winds at the surface for both of the airports. So at the time, KMDH was reporting 290 at 16 knots, and then Paris was reporting 240 at 9 knots. Now, we obviously, if our cross country is like an hour, we're going to probably have a little bit of a different value at the destination rather than what was reported before we left. But we can probably assume it's going to be fairly similar. But that's why we, again, listen to the weather on the way there, right? To make sure that there aren't any giant changes that have happened. Okay. So I've got those and then winds aloft. So 250 at 29 where the winds aloft for this particular day. And I also have temperature because that is going to be important as well, right? We need to figure out our density altitude. So -3 at altitude, and I believe I chose the 5,500. You can see above 7 degrees at KMDH and then 8 at Henry County. Okay, and I've also taken some what am I trying to say? Some METAR information, right? So the altimeter settings I've also taken. And this is something that people might do differently, but you can see I have 29.87, and then 29.91, and then 29.89. And what I've done here is I have found the average pressure setting for the stations along the way, so I can have a pretty correct pressure altitude the whole time I'm on the cross. So how I did that, if I find my briefing here, how I did that is I just went through all of these stations here and I just got an average for the pressure setting. So you can see here we have a pressure setting as low as 2996 all the way up to 3001. So honestly, you could do it that way too, right? If I take 3001 and subtract the 2996 from it, then that gives me a difference of 0.05, right? And then I can just divide that difference in half to make it, or I guess times it by half to make it smaller. And that gives me 0.025. And then I would just add that to the lower value to give me just an average. So like the average altimeter setting is like 29er. We'll just say it's 29.985, but I just rounded it up. So 29.99 would be kind of the average altimeter setting that I would use to calculate my pressure altitude for everything. So that's just kind of how I did that. If I'm really bored, I like numbers, so if I'm really bored, I will add all of these and literally average them out, which you don't have to do if you don't want to do. That's just something I do because I like numbers and I like being very precise. So continuing, so that's how I got that information. And this is the altimeter setting that I will use to figure out my pressure altitude for everything. My pressure altitude at departure at KMDH, my pressure altitude during cruise, and my pressure altitude at the destination. If you look at the top of this shot, you can see the altitude I've already selected is 5,500. right? And if I am going to find the pressure altitude for 5,500, then I would take my standard pressure, like as we've done in the past, and then subtract that average, right, the 29.89 from it, and that gives me 0.03 times that by 1,000, right? We're converting that to from inches to feet, and that gives me an adjustment of 30, right? So then I would add this 30 to all of those things. So 411 plus 30 gives me 441, right? For my cruise pressure altitude, I take the 5,500 and add the 30 to that. That gives me 5,530. And for my destination, 580 is the field elevation. Add the 30 to that, and that gives me 610. So I've done that for calculation purposes. I keep the actual altitudes I will be at outside of my parentheses, and then I'll put the pressure altitudes beneath them in that same box in parentheses. Okay, so that way I've got some information. The last thing I want to talk about is because I like to be precise, I will take my winds aloft and my winds at the departure airport and kind of find a medium between those for the climb. And I like to factor in the wind for the climb because that chart does not do that. So I do that personally. Okay, so my if I find the middle between 250 and 290 for direction, I get 270, right? So that's easy. And then for velocity, there's a difference of 13. I just kind of picked either 6 or 7. It looks like 7 in this case, right, and added that to the lower value. So my wind during the climb would be something like 270 at 23 knots, okay? There's got to be transition somewhere to what the winds aloft are like, and this gives us maybe a closer idea of what the winds are actually doing, okay? My top of descent down to my destination, I did the same thing, right? So 250 and 240 for the direction. Between those is 245, sorry. And then 29 knots compared to 9 knots. Well, that's a 20 knot difference. Divide that by 2, and that's 10. And then you can subtract that from the top value or add that to the bottom value to give you 19. So again, it's just kind of an estimation of what the winds are going to be like when you are climbing and descending. All right, so moving on, we've gone ahead and selected an altitude, right? But just remember what your options are, legally speaking. So we were between the 3,500 and the 3,500 and the 5,500. And we use the winds aloft in the briefing to make a decision, right? So essentially what we are trying to avoid is a headwind. If we have to have a headwind, we want the lightest headwind possible. That way we spend the least amount of time out on the cross country, okay? So don't pick something super extravagant, right? For this cross country, if I would have picked 7,500 or 9,900, I would spend most of my time climbing, and the cross country itself would take more time. So don't pick a high altitude unless you are going quite a distance and it makes sense to do it. So now is the part where we go in the POH and we go through the cruise performance values, right? So this is exactly what we've done before, and hopefully this will give you guys some more practice with the cruise performance interpolation. I know we didn't do a ton of that in class, and I apologize for just like not doing the best job of explaining that, but I'm going to try it again here in a second. So don't forget the notes, right, when you were looking at these charts, because the notes are often very important. When you go in the cruise performance chart specifically, you need to choose an RPM setting. Remember to make sure that it is the same for the pressure altitudes that you will be interpolating between, okay? So make sure it's the same. If you want to go at 2200 RPMs, make sure it's the same for both. It's not going to be in the same exact place for both, but make sure that you choose both pressure altitudes at 2200 RPMs. Okay, so underneath my runway drawing at the top of my navlog, I have my RPM setting box, right? So I've chosen 2250 for my RPM setting. So that's what I'm going to stick to in the chart. So remember we used this average altimeter setting to find what the pressure altitude was for everything. So you can see I've got the 441, right, for KMDH, I've got the 5,530, and then the 610 for the destination, right? And what I've done is I found out that my adjustment factor is 30, and I've added that to all of those different altitudes. So those matter when it comes to performance, right? So if I have a pressure altitude of 5,530, then my pressure altitudes that I will be interpolating between are 4,000 and 6,000, okay? So immediately what I want to do is I want to go ahead and find my 2250 settings for both of those. So here's my 2250 for 4,000, and then here's my 2250 for 6,000. You see what I mean? How they're not exactly in the same place? So the higher up you are, right, the higher the available RPM setting. So it's going to shift places on you a little bit, so just be careful there, okay? Now, remember how I also had the temperatures there along with my wind information? Well, that comes into play again here as well. So we saw that there is a temperature of -3 degrees at my cruise altitude, right? If we go off of a standard atmosphere, so if we say that the temperature down at the surface is at sea level, I should say, is 15 degrees Celsius, and we're losing 2 degrees per thousand, how much are we supposed to lose on the way up? Well, if we're losing 2 degrees per thousand, we are climbing 5.5 thousand right above sea level. So 5.5 times 2 gives us 11. So we are expected to lose 11 degrees as we climb. Okay, so we would take our standard of 15 degrees Celsius at sea level and subtract the 11 from that to give us our expected temperature at 5,500. So that would give us 4 degrees Celsius. Okay, 4 degrees is unfortunately not what is reported, right, or forecast, I guess I should say. It is actually -3. So is -3 above or below standard at 5,500? It's below, okay? So what that tells us right away is that we will be interpolating between the 20 below and the standard temp columns, okay? So between those two, and how many degrees below standard is -3 degrees? Yeah, 7, right? 7 degrees below. Okay, that column there is for 20 below though. So again, we have to go somewhere between those two. Okay. Now, what I've done at the bottom here in the notes section is I've just gone ahead and set up our classic interpolation method. Right? I don't have the line, so it's not a nice, neat grid. Don't come after me, please. But all the information is there. So again, I figured out I'm interpolating between the 4,000 and the 6,000, and I've got my 5,530 between the two. Okay, and then for my temperature, right, my standard temp column just says standard temp, but I know my standard temp that I'm expecting is 4 degrees, right? So I've written that in parentheses next to there. And then my other column that I have available is 20 below, right? It just says 20 below standard. So what I've had to do is take my 4 and subtract 20 from that. And it says -14 because I can't do math, but it should be -16, right? That is 20 below standard temp. Okay, and we would go ahead and interpolate for that 3 degrees as well as the 5,530. Remember, the only things that we are concerned about are knots and fuel, right? So we want true airspeed and fuel. So the values that I'm concerned about, I am underlining right now. Oop, that was not good. Okay, so let's go ahead and interpolate the temperature first. So let's start with the 4,000 foot pressure altitude and we'll interpolate for the temperature first. So let's start with knots of true airspeed. We have 115 under the 20 below column, and we have 114 under the standard temperature column. -3 is, remember, 7 below standard. So it is a little bit closer to that, right? Because remember, the -16 that's supposed to be there is 20 below standard. So that would be a difference of 13 rather than 7. So the true airspeed I've decided to go with is 114 knots. I'm not going to try to interpolate between those because it's hard enough to maintain 114 knots compared to 115. In all truth, we will probably just have 115 knots of true airspeed. But yeah, that's what we'll do. We'll choose 114. So that's what I've got in the middle for that. And then after that, I've interpolated for fuel burn, right? So that one, it might be a little bit incorrect because I've used the -16, or maybe not. So what I'm doing here is I'm first finding the difference in gallons per hour between the standard temp column at 4,000 and the 20 below temp column at 4,000. Okay, so if I subtract the 9.2 gallons per hour of burn minus the 8.6, that gives me a difference of 0.6, right? If I want to figure out how much change there is per degree of difference, right, then that would be, I would divide that 0.6 by 20, okay, and that gives me 0.03, okay? So if I know that my temperature, if I know that my gallon per hour burn is changing by 0.03 per degree of change, then I can factor that in, right? So be careful here because the values are a little bit different than we're used to, right? We're used to seeing for a lower temperature, the value is less, right? But here, the 9.2 at 20 below is greater than the standard at 8.6. So we still want to follow the rule of adding to the lesser value. So in this case, it belongs to the standard temperature. And we said that our temperature of -3 is how many degrees away from standard temperature? It's 7. So we would need to multiply the 0.03 times the 7 because there are 7 degrees there. And that gives me a value of 0.21, okay? And remember, always add to the lesser value. So I would add my 0.21 to the 8.6, and that gives me 8.81. Now, I'm just going to call that 8.8 because it's hard to deal with that hundredth place, right? We're not that concerned about that. So remember, always just kind of round it off. I always say round up to the worst performance. So I guess I'm not following my own rule here, but it's just the 8.81 is so close. But if you want to be extra safe, you could call it 8.9. Okay, so hopefully that makes sense as to how we got the 114 and the 8.8. I did the same thing for the 6,000 foot pressure altitude. So I took those values, right, and I picked the ones that made sense for the airspeed, right? So 115 compared to the 114. I chose the 114 because again, the temperature of -3 is slightly closer to the standard temp, and it's a slower cruise airspeed anyway. So I chose the 114 again, and I did the same thing for my gallons per hour, right? I subtracted the 8.1 from the 8.7. I got 0.6. I divided that by 20. So that's how much. So there's 0.03 gallons of change for every degree. And remember, we always add to the lower value. So there are 7 degrees between the standard temperature and our actual temperature. So I would multiply the 0.03 times the 7. That again gives me 0.21. And then add that to my 8.1. And that put me at 8.31. And I guess there I followed my rule and I rounded up to the 8.4. So again, I mean, it's tenths of a gallon, but it does kind of make a difference at the end of the day. So I'd say just be safe and just round it up. Okay. All right. So anyway, we've got 114 right on either side for our true airspeed. Now we have to interpolate for the pressure altitude, right? So I mean, if it's a true airspeed of 114 at 4,000 and at 6,000, then it's going to be the same between that, right? So we were able to just keep the 114. So that was very straightforward. And then our fuel burn, right, we had to kind of figure out there. So again, we're taking the difference between our reported values. So according to my math, 8.8, I would subtract the 8.4 from that. That gives us a difference of zero point 0.4 gallons between the 4,000 and 6,000 foot pressure altitudes. And all we're doing is we are, again, dividing that by 1,000, or I'm sorry, 2,000 in this case, actually. So 0.4 divided by 2,000, because that's the difference between 6,000 and 4,000, right? Okay, so that should give me a very small value of 0.0002. And then all we are doing is we are figuring out the difference between the 5,530 and the 6,000, right? Because the 6,000 has the lower value. Again, I know it's a little bit weird because the lower value usually goes with the lower pressure altitude, but that's just not the way it works here. Take the lower value and the higher pressure altitude, find the difference there. And the difference between that is 470, right? So if I take my 6,000 and I subtract 5,530 from it, then that gives me 470. So I would multiply my 0.0002 by the 470, and that gives me 0.094. And what I would do is I would add that to the 8.4, and that gives me 8.494 as my burn. And then I would just round that up to 8.5, right? So that's how I got the 8.5. So again, make sure you don't forget to read the notes. You can see here that at the bottom, right, it always says if we don't have speed fairings, then decrease your true airspeed by 2 knots. And we don't have speed fairings at all at SIU, so it's -2 for that, okay? So we end up getting a true airspeed of 112 knots and a gallon per hour fuel burn of 8.5, okay? So I have gone ahead and I've put the 112 in the lower box for the airspeed for almost every pair of boxes. The first one I've left out because that's going to be my climb, right? And my airspeed is going to be different during the climb. But I've put 112 here the whole time. I have included 112 for the top of descent to destination because I'm going to try to maintain that same airspeed until I get to the pattern. Okay, I want to keep myself moving. Okay, so 112 for all that, and then the 8.5 I put underneath the fuel burn and remaining column here, just to have as a reference. Okay, so that's how I did that math. I hope that makes a little bit more sense than the last time I tried to explain that. If you follow along with your calculator, you should get the same results that I get. All right, we've got that information. The next thing we're going to do is consult the time, distance, fuel climb chart. We've already kind of gone over this in class before, but remember this chart is just kind of an estimation at best. We will look at the notes to make sure that we are doing everything that we're supposed to do. And then for the chart to be somewhat accurate, you do have to do a little bit of interpolation for pressure altitude. You don't have to go super crazy on it because this chart again is an estimation at best. And let's see, the E6B, I didn't really think about how I'm going to show you guys that. I think I'll just do it online today. You will learn how to use an actual E6B as time goes on. Maybe I'll bring one to class today a little bit. But you would use it to figure out ground speed and fuel and time calculations after you use this chart. But right now, let's focus on the chart, okay? So if we go back and just kind of remember what our pressure altitudes were, we're sitting at 441 here, and then we're climbing up to like 5,500, a little bit higher than that. So why don't we go ahead and call our starting pressure altitude 500 and our top altitude 5,500. Okay, so all we're looking to do is find the different values for time, fuel, and distance between the two. And it's just math. okay? So if I go between my 5,000 and 6,000 on the pressure altitude chart, and I follow that over to time, um, if I interpolate to the middle between 5,000 and 6,000 to 5,500, then it would take 9 minutes, right? So all I'm doing is just finding the middle, right? Finding the difference between the two and then adding half of that. So I get 9 there. And then if I do the same thing for sea level and 1,000, I get the time reduction because of my starting altitude there. So between 0 and 1 minute is half a minute. So 9 minus zero point 0.5 minutes is really 8.5 minutes. I don't want to have half minutes, so let's just keep it at 9. Okay, so keep these numbers for the time nice and neat. So let's just say it's going to take us 9 minutes to do the climb. And then fuel, we would do the same way, right? So if I go between my 5,000 and 6,000, that's a little weird because it would really give you 1.95 because there's a difference of 0.3 between those. But let's just call it 2 gallons. Okay, so 2 gallons, and then between sea level and 1,000, we get a nice clean number of 0.2 gallons. So we subtract that 0.2 from the 2 to get our total burn during the climb, which we would call 1.8 gallons for the climb. And then for distance, same thing, right? Between the 5,000 and 6,000. Again, it's a difference of 3, so that would really put it at 12.5 for distance. Let's call it 13. Let's plan for 13 miles. And then between the sea level and 1,000, right in the middle of that is 1. So if we go 13 minus 1, that gives us 12. Okay. So roughly this climb should take 9 minutes, an estimated 9 minutes, 1.8 gallons of fuel burn, and then 12 miles. Let's go ahead and incorporate note number 1, right? So we will add 1.1 gallons of fuel. Now, for me personally, I like to add 2 because I just like to round up and be extra safe. So if you want to add just the traditional 1.1, that's fine. Or if you want to add 2, that's also fine. So for me, the climb again would take an estimated time of 9 minutes. My fuel burn would now be 3.8, and then my mileage would be 12 miles. There's also a note to increase time, fuel, and distance by 10% for each 10 degrees above standard temperature. But in both instances, we are below standard. So we were showing a temperature of 7 degrees at KMDH, which is even less than is standard for the surface, or I'm sorry, for sea level. And then -3 is not standard for 5,500, right? We found that 4 degrees was standard. Okay, so we don't need to follow that note at all. So that's essentially all we've had to do for the climb information. And then what we can now do is if we know that our climb is going to be about 12 miles of distance according to the chart, we can go ahead and put it out here on the sectional. We can mark where that's supposed to be. And you can see it does precede our checkpoint at I-57, right? It's about 5-ish miles before then, 5.5, something like that. But it is before then. Okay, so we went ahead and we made that mark using the plotter, we measured it out, and then now we can kind of fill in a little bit more for our values here, right? So I have a little bit more here than we've actually found out so far. Let me just give you an overview of what we have found out so far. So we know what the magnetic course is. Again, don't fill out the column the way I did. That's apparently wrong. And then altitude and pressure altitudes, right? We've got those, right? So pressure altitudes are in parentheses. The wind, direction, velocity, and temp information I've just copied from the weather briefing I got. So I got the surface one for KMDH, that's the top box, and then most of the other boxes are my one winds aloft station that I was using, which is I think maybe Paducah when I planned it originally. And then the winds that I have between top of descent and the airport are the interpolated values that I found between the reported winds on the surface at destination and the winds aloft. Okay, so that's where I got all those values from. We found out that we would have a true airspeed of 112, so that's where that comes from. The 77 comes from the climb chart. I just grabbed that as kind of an average climb speed. So if you look, right, your climb speed decreases as you go up. So I've just chosen 77 as kind of a middle. You can see it ranges all the way from 79 down to 74, and I just chose 77 as an average figure. You can leave it at 79 if you want. It doesn't really matter. Okay, so I've got that information. We figured out what the true course was when we drew our line at the beginning. Ignore the wind correction angle for right now. That's E6B stuff. And then the 2 degrees and 3 degrees, right, for the variation we found. Distances we found, right, now that I know my top of climb is going to take 12 miles, I can throw that in there. And then now I know it's 5 miles, right, from top of climb to I-57. And then I've got most of the other distances in there. Ground speed, don't worry about. Time, don't worry about right now. And then my fuel burn, I've put in that chart as well. I did not put in my additional 2 gallons, so make sure you do that. Don't be like me, or your additional 1.1, depending on how you want to spin it. But I will put that in with the first value usually. So it should be 3.8 instead of 1.8. Okay, so that's where I've gotten everything so far. And oh, actually, let me look at the second chart and see if there are any differences there. Yeah, so these are all wind correction things with the E6B. For those, you can, yeah, let's do it online so you guys have a little bit of practice. I'll try to talk about it in class today, but know how to use a real E6B. If you go to CheckRide and this is what you pull up to do your calculations, they're not going to like that. They're going to want you to use an actual E6B. So make sure you know how to actually use one. Okay, let me go back in this and steal some wind information out of this. Okay, so let's go between the top of climb and I-57. It's the same thing for the climb, but let's just use a cruise figure. So we have 250 at 29 knots. So sorry for all the back and forth. We have 250 at 29 knots. So wind direction is 250, and then speed is 29 knots. Our course, our true course that we figured out was 154, right? And you always want to go off of the true course. You can even see it in the way that the nav log is arranged, right? You've got your true course, and then from there, you would get your true heading. Okay, so we want to go off the 154. And once we do that, this lovely, lovely, lovely app will give us information, right? They'll tell us that the wind correction angle is 17, and our heading is now going to be 171 as a result of that, and then our ground speed is going to be 99. Let's see, did I do that correctly? Ground speed. I guess maybe I did not do that correctly. Don't know what I did wrong there. But anyway, that will give you the values you need. So you would have a value that goes in as your ground speed, right? You would have a value that shows you how much wind correction you need. Almost got that right. I don't know what I did wrong for the ground speed. Let me make sure that my info I have in here is correct. 154. This needs to also be 112, so make sure you change that. Okay, that would do it. That's why I didn't have the correct numbers. I was like, I thought I did this right. But you can see I get a wind correction angle of 15 degrees, right? And positive 15 means that you're adding the number to your true course. If you got a negative number, that would be a subtraction, right? So you can see visually here we have pretty much a direct crosswind. That's why our ground speed is not that much different. So I would put all these values in. So if I get a wind correction angle of 15, then I would add the 154 and the 15 to give me 169. And then I could even go as far as to add in the variation, and that gives me a magnetic heading of 171. And then my ground speed information I put under the appropriate column, right? So 111 is next to my distance for that. Okay, and then from there, I can figure out how much time it's going to take. You can use the E6B for that, or you can use easy math. If I have a ground speed of 111, I know that if I'm traveling at 60 knots, I'm moving a 1 nautical mile every single minute. So what I can do is I can divide the 111 by 60 to give me a rate of travel. So I know that I am covering 1.85 nautical miles per minute if I'm doing a ground speed of 111, and then I can take this and divide this by the distance, right? So 5 divided by 1.85 should be about 2.7. So it's going to take me about 2.7 minutes to travel 5 miles or 5 nautical miles. Okay. So what I've done with the times here is at the very beginning, I started with my time off, or my planned time of departure, right? So I figured I was leaving at, I think 9 a.m., I guess. I think I did in Zulu, so 9 a.m. And my climb would take me 9 minutes according to that ground speed. So I should reach my top of climb at 1409 Zulu. And then at 1409 Zulu, right, I should be leaving my top of climb and continuing to my first checkpoint, which is 157. So that's where I just got that 2.7 from, right? I figured out what my rate of travel was. So how many nautical miles am I covering a minute? And then how many miles do I have to travel? And divide that by my rate of travel. And that gives me the time it takes for me to do that. So 2.7, I just rounded it up to 3 minutes. So I added 3 minutes to the 1409 Zulu to get 1412 Zulu. So I should reach my next checkpoint around then. If we want to do another example, again, I said 111 divided by 60 gives me 1.85 nautical miles per minute. I am going 20 miles, so I will divide 20 by 1.85 for my next one, and that gives me 10.8 minutes, which I will call 11 minutes. So that's why I will be reaching the Ohio River at 1423 Zulu, right? I start from my I-57 checkpoint at 1412, and it takes me about 11 minutes to get to the Ohio River. So that's how you calculate the rest of that. And then if you have that information, you can again use the E6B if you want online to figure it out. But if I know how many minutes I'm going to be in transit between these points, and I know how much fuel I'm burning per hour, then I can figure out how much fuel I burn on each of these legs, right? So if I go back to the top of climb to I-57, right, that's 3 minutes. I can divide that by 60, so that gives me 1 over 20, or 0.05, or 5%. 0.05, right? If I know that I'm spending 0.05 hours on that particular leg, then I can multiply that by the 8.5, and that should give me a fuel burn of 0.425 gallons, which I'll just call 0.5 gallons. Okay. For my next one, if I'm taking 11 minutes to get there, I will divide my 11 by 60 to convert that portion of an hour to a decimal. So that gives me 0.1833333 repeating. And I will times that again by the 8.5, which is my projected fuel burn per hour. And that gives me 1.5583 repeating gallons burned, but we will call that 1.6. Okay. So that's how you go about calculating the rest of these figures, okay? Hopefully that's helpful. Let's see here. Where's my mouse? I can't find my mouse. There it is. Okay, and then moving on to the next one. That's what we kind of talked about already, right, for the wind correction. So add to the right, subtract to the left. If you've got positive numbers, then you need to add, right? If you've got negative numbers, then you need to subtract. And then throw all the values in, right, to your nav log and everything. as we've talked about. And then top of descent calculations, you've got a few different ways to go about doing this. You can desire a 3-degree glide slope, and you can figure it out from there using the information I have here. Or if you want a particular rate of descent, you can go off of that as well. So for this, right, so to get the distance, if you want a 3-degree glide slope, then you need to multiply your ground speed by 5 to get a descent rate in feet per minute. So if I have a ground speed of 111, then that gives me 555, right? So like 550 feet per minute, okay, is what we would shoot for on the descent. So I would probably write a note somewhere that says on the descent, maintain like 550 feet per minute, okay? In order to figure out how far it's going to be, we need to figure out, number one, how much altitude do we need to lose? And then we need to do a little bit more math on that. So if we are at 5,500 and pattern altitude is 1,000 above the field elevation, right? That's about, I don't know, 1,600, right? Because the field elevation at Henry County is 580. So if I subtract the 1,600 from the 5,500, that gives me 3,900. And we also need to multiply that by, in this case, 0.003. Okay, so 3 divided by 1,000 is 0.003, and that gives me 11.7 miles. So it's going to take me about 12-ish miles to descend. Okay. Okay, and then the other way you could do this is, again, if you figure out you want to maintain, let's say, 500 feet per minute, you could do the subtraction to figure out how many feet you have to lose. So 5,500 minus 1,600, that gives me, again, the 3,900, right? So that's the number of feet I need to lose. Let's say I want to descend at 500 feet per minute. I would divide that 3,900 by the 3,900 by the 500, and that gives me 7.8. Right, so that's how many minutes it's going to take me to lose that if I maintain a descent rate of 7.8 minutes. Now, if let's just make it 8 minutes. So the descent is going to take me 8 minutes. Okay, if I am moving, right, at a rate of 111 knots, right, of ground speed, I divide that by 60 again, I know I am hovering 1.85 miles per minute, right? We said that the descent would take me 8 minutes, so I need to multiply the 1.85 times the 8, and that would be our distance. So 14.8 is what I get, and it would take me 14.8 or 15-ish miles to descend at a rate of 500 feet per minute. And that tracks, right? We calculated that the 550 feet per minute would take us about 12 miles, so it makes sense that it would take us a little bit of a greater distance to descend at a lesser rate. Okay, so that's how I got that information, and you can see, right, we have 12 miles for the descent. I changed, I guess I had different ground speed because of the different winds, right? So just be careful there. Don't always take the ground speed from up there. If your winds change, like they did in my example, then go off of the appropriate ground speed. Okay. So that's how I would go about factoring that in. You can see the math that I've done at the bottom. Feel free to pause if you need some time to kind of comprehend my writing and everything. Okay. And I have my Navlog pretty much completed. The only thing left that I need to do is I need to, okay, so I see what I did. So I added the 2.0 for startup and taxi at the bottom. So I just put that in a random box in the fuel column. And then reserves, right? For legal reserves, you need 30 minutes of additional fuel for daytime VFR. And then if you were going at night, you would need 45 minutes of reserve fuel. Now, how you figure out how much reserve you need is, well, if you know you're burning 8.5 gallons an hour, divide that by 2, and that gives you 4.25. So you would need at least an additional 4.25 gallons on top of the fuel you will burn. Okay. I would call that 4.3 again and then add that. So that's what I did there. If you needed 45 minutes of reserve, right, take the 8.5 times the 0.75, which is 3/4 of an hour, which is 45 minutes. And that gives me 6.375 or 6.4 gallons of reserve. So I would add up all of the fuel that we're burning plus the reserves and put that figure at the bottom. So it's about 15.5 gallons that are required. It's going to take me about 59 minutes to get there, right? So compare your very first time that you have at the top to your very last time. And then go ahead and add up all of your distances between your checkpoints and everything. And it should give you close to, if not your total mileage that you figured out earlier. And that's how you get all those totals for that. And then now, once it's day of, right, you get your airplane, you finish the weight and balance. So go ahead and um, figure that out, right? Like I said earlier, you'll always have full tanks, so that's a given. Just go ahead and grab that weight and balance information. The way you would go and find that information, let's see, how much time do I have? I don't have a ton of time. But the way that you would find that information is you would, let me get rid of this briefing. You would go on the internet, of course, and what I do is I just Google aviation, SIU aviation, and then click on our link here, scroll down to the yellow box, and then RMS is what you want. And in RMS, you need to, your username is jpilot, and then password is fly, all lowercase. Log in, go to resources, uncheck only downed, hit filter, and then all the airplanes that are up and available and those that are downed will populate. Pick whichever one you were assigned. So, oh, 5 for 7, that goes down, but hit the D next to your airplane and then go to weight and balance. And in here, you've got your empty weight, so your basic empty weight, and then you've also got your moment information. It's kind of cut off, so you guys can't really see all of it, but you've got your moment. I tried to move it over, but that's not going to work. You can see a little bit of it. Actually, that's all of it because there's no decimals. Okay, so 70,166. They give you a CG. Oh, and it's at the bottom too. I didn't see that. But that's where you get that information. And then the other piece that's important on RMS is compass. This is where you get the deviation, okay? So the deviation is just kind of the difference between the reported values and the expected values here. So for instance, if you were trying to follow a heading of 030, then there would be a deviation of -2, right? Because what you would actually see or want to see to go 030 is 028. So there's a difference of 2 degrees. You can see some of them have no deviation. For instance, 330 has no deviation. But what I would do here is I would find the values on either side of the expected magnetic heading, and then I would figure out how much deviation there is as an average. So if I do this, if I go back to this really quickly, the magnetic heading looks like it's like somewhere in the 170-ish department. So what I would do is I would go back to that and see that 170 is between south and between 150, right? There's a deviation of -1 for 150, a deviation of -1 for south as well. So the average between the two is a deviation of -1, and I would go back here, and that's what I would put in, right? So I'd subtract the 1 and get a course heading of 166, okay? So hopefully that's helpful on that. So we talked about weight and balance, takeoff landing distances, you guys know how to do those. And the last thing I'm going to talk about really quickly is filing your flight plan, okay? So after you do all this stuff and you know you're going for sure, go on your 1-800-WXBrief.com account and then enter all of the information. There are ICAO codes in the SharePoint that your instructor will direct you to. And once you have all that information in, hit the file button at the bottom, and the flight plan gets sent to the flight service station. And then once you are about to go, if you have an account and a phone number with them and everything, they will generally send you a text to ask if you want to activate the flight plan and activate it. Okay, and that opens your flight plan so that they know that you're out flying. When you land, this is imperative. Do not forget to close your flight plan. You can do it through that text service, or you can call up the flight service station. The 1-800-WX brief number will get you that. Um, but do not forget to do that. If you do not close your flight plan, they will send Civil Air Patrol to look for you because they will assume something has happened to you. I forgot to close my flight plan once, and they luckily didn't send Civil Air Patrol. They assumed that I'd forgotten and they called me, and I had to cancel or close it then, right? So make sure that that gets done, okay? Otherwise, they will assume that you're downed, okay? All right, so hopefully this was helpful. I'm sorry it's almost 2 hours, but please, please, please use this as a guide. Let me know if you guys have any questions on cross-country planning.